I'm Jackie O'Dowd, and you're listening to Connecting the Dots, a podcast series by Realising Potential. Hi, Wei. Good to have you join us this morning. Just as background for everyone that's watching or listening, today I've got the great pleasure of talking to Wei from Kineviz, who has just some amazing insights and capabilities to share on how we meld people and data. And I think, seeing as we're all just swamped with data and information every day, making sense of it is becoming more and more critical for everyone. So, Wei, thanks for joining me today. So first off, tell us a little bit about Kineviz for those that don't know what Kineviz is and what it does.
Thank you, Jackie. Well, Kineviz, we make data analytic solutions, and mostly we focus on providing visual analytics. It's really deeply rooted in my observation from all these years working in the science and the technology field, that when it comes to complete patterns, complete informations, machine is still limited. Machine learning is important, AI is important, but our brain, our mind, we can spot information, we can spot patterns so much faster, so much, our intuition is really good. So in order to leverage intuition, you need to let our eyes see it. And once we can see it, we will see the patterns, and will help us to gain the insight in the data. So that's why we focus on visualization in our solutions. And more specifically, we'll focus on highly connected data, so-called the network graph data. If you haven't heard about graph, it just means network. And high dimensional data, something, or the high dimension sounds very fancy. In reality, it just means something has many properties. That's it. Or a CSV file has many columns. That's it. When you have so many columns, trying to visualize it, trying to understand it, often become difficult.
Yeah, I struggle with really large Excel worksheets. They're just rows and rows of numbers. Yeah. And you're right, it's hard to pick out what's important and what's not. And I think we'll share a little bit as we get into the conversation, some of the things that we've actually used Kineviz for. And it's mind-blowing what you can do with it. Tell us a little bit about your team. You've got a diverse group of computer engineers, scientists. It's a good mix.
Yeah. Well, one thing that most people do not know is actually, I would say majority of the people in Kineviz, they're artists themselves. So that's kind of connected to how Kineviz was founded. Kineviz actually was founded out of arts nonprofit, Kinetech Arts. And in around 2012, 2013, where we found this Kinetech Arts, where we bring artists and scientists, engineers together to explore how art and science interface, how art practice can learn from science, and our scientific practice can learn from art. The one thing lead to the other. Eventually, we realized we had to separate anything from business from anything for art. So we created Kineviz, specifically kind of a lot of taking a lot of learning from artistic exploration into business or data visualization. Now, all the founding members of Kineviz, they are artists. And along the way, we attract a lot of artists join our team. And that you can see from our product, that kind of often have, I think we push the boundary a little bit more than other people because of it.
Yeah. I think the visualization's got such a great place now for just about every business. Like we said before, everybody's working with lots of data, but there's lots of different sources of that data, and trying to bring it together to form a holistic view, or the best view that you can form. It's been, up until now, I think it's been really, really difficult. You know, I think we see people living with dashboards and graphs and charts and, you know, magical spinning wheels, but it's all data in a point of time, and it's all built around a specific view rather than giving us an exploratory view. And that's one of the things I think the graph data allows us to do. It allows us to explore and almost wander through the data to see, what does this mean? Why is that there?
Jackie, you nailed it. The explorative is the key. I see how enterprise use data has two sides of same thing. There's explorative side and there's operational side. They have somewhat different requirement. When you explore something, and in fact, the most important question is what question to ask. You don't really know what question you're asking. So this is actually, if anybody doing art, making dance, creating music, they will tell you the same thing very often. Like, I think, what is the, you know, the minimalism musician, what's his name, from New York? Anyhow,
I don't know.
Philip Glass. Yes, he once famously said that he does not know what he was making until later stage of composing, and then he realized, oh, that's what I was making. So his work has a lot of exploration in his music composition. Same thing with the data analysis. Like when you at the explorative phase, you really have to formulate a lot of hypotheses and test it quickly through the way. And you look at the patterns, look at the signal comes up, quickly help you to formulate new hypotheses. So it has to be a very fast feedback loop, iterative feedback loop. It's not like something like I want to do A, do B, do C, do D, and then I get the result. Never ever happened this way. However, once you identify signal from your data stream, and then you want to repetitively apply the same method, like look for same patterns from your data stream, now you get into the operational side. With the operational side, the emphasis shift towards detecting these patterns you already recognized. It's no longer to detect like a new pattern you have never seen before. It's rather than, hey, I know this is the signal I want to detect. I want to detect really well, really fast, high authenticity, very precise. So that's a very different requirement. And so for data visualization, I think we're mostly focused on the explorative data analysis to help people to see the information, see the patterns, to figure out what the question is there to ask, and then to do it very quickly. And this is why we very emphasize about how can you easily get data to visualization, and get data, and how easily you can manipulate data, change its format, extract new informations. Because most of the time, I would say, like, well, from our experience, people often has a CSV, has a JSON data somewhere. And if you ask them to inject into a database and then, or write a program to load the data, it takes a lot of time. It takes too much time. Often by the time you set up all your two chains, you already forgot what's your question in your mind. So it's actually really important to let people to just drag and drop a piece of file into a canvas, and boom, you see the data come out in some form that allow you to stay in the flow, to to stay with your data, stay with your question, and quickly formulate new questions, answer your questions. So the speed of getting from the data to the visualization, and the speed from having a question to formulate how do you examine your question, that to me is really the key in explorative data analysis.
So does it work well with both, I'm going to say, simple data sets and simple questions? And can it translate just as well to complex data sets and complex questions?
A complex question very often is just a simple question in disguise.
Yeah, I guess it is.
Yeah, very often it's like I used to be a physicist. I was trained a physicist. So as a physicist, we're trained to model everything in the that we see, we touch. Like we have this hammer to hammer everything with the modeling. But however, it also teaches us to look for the simplest form of explanation, look for simplest form of the question, and more often than not, that actually leads you to the discovery much faster.
I've been on a project recently where I've been working with some legal teams who ask very deep nested questions and provide a lot of data. So in order to try and to find the answer, the simplest answer in the fastest possible way. And it's been quite interesting to take a load of what I'm going to say unstructured data. So, and I'm talking many, many, many thousands of documents in various file types and sizes, and bring that together, and using Kineviz to blow that out and to start looking at the relationships. So what are the documents that are really important? Which subject area has the most documents or data associated with it? Who were the authors of those documents, and what are the relationships between those authors? So you can, and then what dates did things start to happen? So you can start to put together a picture of events. So you start to better understand the chronology, and then look at the relationships, then look at the content. But the data needed to have some sort of search criteria across it. So it's, what am I actually looking for? And sometimes we don't actually know what we're looking for.
Jackie, you just described a real world example of data analytics, and the real world example, the real world cases is always messy, dirty, and we can formulate as good a model, as simple, as beautiful model as we want, and when you touch the real world, it very often falls apart, and this is why there is an interesting philosophical difference between Western philosophy and Eastern philosophy. The Western philosophy very often focus on the nature of things, focus on how do you define things, which is very, very much responsible for the leap of science technology development a few hundred years ago in Europe. The Oriental philosophy, like Chinese philosophy, since I grew up as Chinese and I'm very familiar with philosophy. And so if you read the Chinese philosophical book, the very first philosophical book, the Tao Te Ching, which is considered the Bible of Taoism, the first two verses basically says, if you name something, you probably got it wrong. And also, if you're trying to get the nature of things, you're probably looking at the wrong question. And the nature of something does not exist until it gets into touch with the environment. However, the environment always changes. Thus, the nature of things is always shifting. And you taking that to extreme, and then you just throw up your hand. It's like everything's changing. Like there's nothing you can tell, nothing you can know. Thus, I should not do anything. And this part of the reason why China, science technology in China stalled a few hundred years ago, while in Europe it took off. However, in reality, now the programming is developing really fast, and a lot of early promise of the object-oriented programming, and also like where you build something, you build a class, and then you build an object, is exactly following the Western philosophical intuition that everything has a nature. If you design the nature, you can produce things, and then you can inherit things. You can morph things, and all those things designed so you can reuse what you have built. But in the practice, what's found out is the edge cases always ruins your day. When the edge case come and you have to change your nature, and the edge case come again, you have to change your nature again. After a few iterations, your solution become a giant monster, massive monster. Same thing with the semantic web. It's the effort of connecting all the knowledge out there, and so you can, by creating definitions, you can connect everything, and you can reason. You can do inference. You can derive new knowledge. That was the connecting all the knowledge and derive new knowledge was the goal. In reality, it was too difficult. That promise never realized. And so this is really why I felt like when it comes to data analytics, that we often face the same situation. Like if we want to come too close of really define what it is something, and come from there, like we come from complicate like a system, a schema, manage a schema, and manage the figure out exactly what it is, and then go for it. It often very slow and very often lead you to a long path. A data model that allow you to practically model information without paying too much attention to the fundamental correctness, and that model is often get you to solution much faster and be more flexible, more practical. So I found that in the label property graph. Label property graph is really just like similar to relational data model, which is you have tables. Each table is some sort of entity, a list like a person table, a job table, a company table. And unlike a relational data model, you use foreign key to link them. In the label property graph, you just record like this person work in this office. This office is located in this country. So you just record those informations, and sometime you might realize, hey, this person may not fit into this person table. Well, we can just add a new thing or append to add edge to this new entity. So that is pretty flexible. Of course, it forces the people who is using the model has to pay more attention, because now you need to you can't just hands off, let schema take care of everything. You have to be more you have to know a little bit more intimate details. But very often in the explorative phase, this is exactly what you need. You don't want something overkill, something overly defined, refined. You want something very practical to get you moving very fast. And of course, once you go to the operational phase, which in that situation, you deal with the set of conditions, environments, and the data is highly uniformed. In that situation, if you should have a very set, well-developed schema, and to help you to manage your information in an ongoing base.
Yeah,
I said too much.
No, that's great. Have you got? Can you tell us about some of the projects that you've worked on where you've got those simple lists and some of the great things that you're able to do with that. And then some of the where you've got more complex data sets, where maybe even there's areas where you've struggled with your background, because it gives everybody hope that they can do it themselves.
That's an interesting question. The challenge is a lot of cases we're under customer confidentiality.
Yeah, we're the same.
I can see some. I can just use the example of a data stream. It's like it's a pretty high volume data stream, about 20 million data points per day. Involve many players, people's like accounts, and you want to detect whether there's any fraudulent activities, and you detect any collusions among group of people. Of course, if you just plot them out, and you can look at the summaries, daily summaries, individual player summaries, you can write your machine learning code to detect that. They work pretty well with like individual activities, like some people starting to do something really weird, and you can catch that. But when it comes to group, suddenly information gets really distorted. Like the noise really covers the track. So in that situation, my approach is like, hey, can I find a way to establish connections among different players? Turn out, yes, you can. There's a lot of information you can use, like where do they log in from? Do they log in from the same account, same IP address? Or if they use same IP address, it's very clear they're related. And do they always go sequentially one after the other? If they do, they clearly associate with each other. In this particular case, you also see, hey, when do they create their account? Create their account. If they create account on the same day or same short amount of time, a lot of account being created, of course they're related. So once you class them in that way, and then you can somehow put information together if you look at it, and then like the collusion behavior just jumps out at you. It's so clear. This is really good example of when you can define correlations, like how things related to each other, and bring the information together to look at it, and the signal just like becomes so clear. And if you don't do that, if you're still in the traditional like statistical analysis, that's very difficult to do. So that's one example. Yeah.
Do you think organizations struggle with getting the right data together to put into the graphing databases to do the visualization?
My experience is the companies mostly already have the data organized. I wouldn't say that about 10 years ago. 10 years ago, okay, I came from semiconductor industry. Semiconductor industry was the pioneer in organizing the data, in logging the data. Back in time, we log every bit of data, like collecting huge amount of data from the tools. And those data is crucial for like tool analysis, like health analysis, like yield improvement. The rest of industry, the other industry was not there yet. Like a semiconductor was crazy because like just the cost of building each wafer is so high. So they developed that capability earlier than other industry. Today, when I look at the industries that from public safety to health to insurance to enterprise, the data collection, that part has always been done, from my experience, been done pretty well. What's limiting the company is the data, often everybody understood there's value in data. We just collect the data and store them somewhere and hoping the value will be generated. And in reality, it does not. So a few years ago, I read Gartner and their forecast. They said like, I think at that time they're like 85% of the data lake will be eventually abandoned, because collecting data is one way. To making sense of it is much harder.
Yeah. One of the things that I've found is, and you've just touched on it, is the value. Right? Everybody sees there's value in collecting data, and there's no doubt there is, because you need the great data sets. But I think it's understanding what the value that you want to drive out of that data is. Because different people have different views of what value actually is. Some it'll be accuracy, some it'll be volume, some it'll be understanding the velocity of the change. Others just want to be able to see that it gives them a different level of capability. So it's really interesting when we talk about value and data and the value that it delivers. Because I just find organizations don't determine what the value of data actually is.
Yeah, in the way, I don't blame them, because getting value from data is hard. It's not easy task, and I see a couple obstacles to making the data drive the value from data, and most of the data value people driven from so-called statistical analysis, like that BI, a dashboard, statistical. So that gave you some value, but a lot of the things like the example I should tell before is in identify the network, the correlations, and that is actually a traditional data store is often ill positioned to derive that value. However, traditional data store is important to have. What people missing is a secondary layers of you can keep the data in your traditional data form, but you need to pull the data into a graph analytical analytic data platform to perform more advanced analysis. This also dealt with a key problem in data organization, the data capture. The key problem is I go back to Oriental philosophy, everything is constantly changing because the environment comes changing. And guess what? I tell you example. My friend used to work for IRS, the American, the Internal Revenue Service. Yes. And they have this relational model to store all the data, right? But from year to year, the laws change somewhere. The something tweak a little bit to try to keep it consistent. It's hard. To try the data you captured this year to work together with the data captured a few years ago. It's how difficult. Think definition change, and maybe some zip code disappeared, some boundaries, some shifted. And so you're trying to bring the data together because the environmental change shifts. And it's become very difficult. Often in organization, in enterprise, you have multiple departments. Each department manage their own data. They often manage really well in their SQL database or Elasticsearch. It's represents two extremes. The SQL database is very strict schema. Elasticsearch or MongoDB is very redundant, very free. And the different department trying to bring the data together, they realize, oh, you like Japanese and American, what's green, what's blue is different. Some green color by Japanese standard is blue color by American standard. So when you have to name things, put things into category in your very nice organized table, and when you bring things together, you suddenly realize, hey, they don't match. There's too many data, too much heavy data reconciliation needs to be done. And if the data is stored in the like document model, you realize you need too much knowledge of your data to overcome the redundancy. And so bringing those data together is a really big challenge. This is one of the reasons why the enterprise, it's easy for everybody to store the data. It's how difficult for people to drive value from it.
Yeah, it is. And I think one of the things that you touched on, and we touch on when we're helping organizations with their business architectures, like putting the 7 elements together that we always say that they need to bring together, is nothing stays the same. Everything is evolving. So, what happened 5 minutes ago is 5 minutes ago. It's historical now. So what we're looking at is the historical stuff, the evolving stuff, because we know we're going to change that sometime soon. And then we've got the emerging stuff, the stuff that is coming down the chute that we've sort of got some idea about, but not all. How do you see the graph technologies and the analytics that we're working with now? How does it cover that spectrum? So the historical stuff, I think we've done to death. The evolving stuff, I think, is interesting because that's where the Elasticsearch and the graphing really does help us form those relationships. But where do you think the emerging piece is going?
I think the key is stay flexible, but still manage your data in a managed way. I'm looking at there's the 3 key competing data technology for data warehouse. The relational data model is the most mature and most efficient and the fastest. However, it's also most rigid. And if you're trying to change it, like amend your schema, it's impossible. It's hard. Like there was a U.S. flight data, like the U.S. Department of Transportation released all the flight data in every 2 weeks later. If you look at that table, the diversion column is not 1 column, is 9 columns, because there's a 1 in trillion of the chance a plane gets diverted 9 times. Thus, you need 9 columns to record this like a diversion. Wow. And on the other spectrum, you have the document model. The document model often is very flexible, have a lot, and essentially it's carry a graph data, but in a very redundant manner. The challenge for document model is the whoever's using the data has to know the data inside out and be able to navigate the nested data structure, and also managing a change of document data model is difficult because something changed. Where does the information reference? Where do I need to update as well? It's difficult. In the middle, where I see the happy middle, like the Chinese culture, like everything in the middle, and it's not always good. But in this particular case, I actually think there's some wisdom to it. Is the graph data model. Graph data model is a benefit from the relational data model. Well, by the way, by the graph, I'm not talking about the semantic web graph. That's like a RDF. That graph requires a lot of work in creating exact definition. Often figure out the definition takes majority of the time. The practical graph model is label property graph, and it's actually developed in 1970s. And because it's more computational, complex and demanding, so it lost to relational data model. But around 2006, 2007, the Neo4j founder kind of came to the same place and invented the graph, a label property graph again. And that really is taking the relational data model. You have the tables. Yeah, the tables is really nice. Tables are very useful. If you can put information in the table, hallelujah, that's great. and edge, like rather than restoring the foreign key to link to tables, you just stored edge connections. And such data model has the benefit of being very flexible. Let's say, for example, the flight diversion situation, right? In the relation data model, you have to add another column for every flight. Well, in the graph data model, you just add a new node, diversion, append to it, the next diversion, append to it. And so you can capture that edge case very easily. Like you can capture the change of definition. You can just add amendment. Like for example, the Soviet Union was a big country, and then it broke apart. And what does a Russian mean as a Russian? What does Ukraine mean as Ukraine? And well, if you have a relational data model, to capture that information precisely often requires a lot of effort because there's a change over the time. In graph model, it becomes much easier to deal with. The condition can be expressed as a node attached to it. And so that brings you a lot of ability to capture, to go along with the changing nature of the environment. This is why I feel like the label public graph is really a very practical data model to deal with the practical problems.
Have you got an example of a graph model that you can share? Is there anything on the Kineviz website that explains what graph databases are, what graph models are, and why they're useful?
I think Neo4j did a really good job of educating the market about it. I would highly recommend people take a look at the Neo4j's, like the documentations about the graph, and especially they have a Neo4j sandbox, which is amazing. In they capture many different use cases of a graph, from the fraud detection to crime to supply chain, to medical space. So those are some really good resources.
Okay, that's good. I think it's handy for people to know as to where to go and look. And you've written a couple of papers as well, haven't you? You've written a number of papers on modeling and some of the experiences that you've had in pulling all of this together, because it's a big journey. Yeah,
so that's you actually point out some activity I've been not doing very well. I should have wrote more articles and blogs, and so I'm actually right now I'm trying to write one blog every 2-3 weeks, and to capture those experience and knowledge and thinkings. And so if you go to Medium, Kineviz, you will probably see a large list of the blogs that are coming out.
Yeah, no, that's good. Blogging is always hard. Finding the time to do it is difficult.
Yeah.
And just knowing what people are interested in. So it's actually a great use of time rather than a waste of time, and it's just more noise. So I look forward to those. One of the things that we're working through now is looking at organizational architectural data, so looking at structures and relationships and transactional data and bringing it all together so we have a better shape, so we can look at what is strategic activity and timing and data. We're driving a lot of information out of processes. So we're taking this, I'm going to say an interactive process model, but starting to take that now, which is a great starting point for most businesses, because most businesses have them. They just don't place a lot of value on them. But when you start capturing systems and the roles and the types of data and information that get captured and used in those processes, you can really start to look at where value in that business is being created, where it's getting eroded and where it's getting lost. And I think that's one of the great things, the 3D visualization of the data. That's where it's really useful, because you take an average process model to an executive or team leader, their eyes glaze over and they go, oh, this is so ho-hum. But you show them the 3D model and then automatically you get, what's that? Why is that there? What's happening? Like you said before, you get a different set of questioning. So I'm enjoying seeing what, I mean, you know, I don't profess in any way to be an expert with this stuff. Brian and Liam pretty much are. So I look at some of the work that they do. All I do is I come up with the questions. These are the questions I need to answer. Do we have the data and do we have the positioning? But pulling the different data sets from places you wouldn't think of pulling it from is a really great exercise to do. And I think it would stretch the thinking of most organizations now, or the people in most organizations now, whether it's in a pocket, a particular team looking at a specific thing where they've got a specific objective or problem to solve, and then looking at where that actually fits and where they can take that to meet the overall strategic objective of the organization. So we're pairing things together, we're not breaking things apart.
Yeah, Jackie, you just like hit a nail on the head, and I think there's a great argument about whether 3D visualization is useful. I actually in a graph convention, there's authors get on the stage that just set out flat that 3D visualization is wrong way to go, and that's not my experience. My experience is, of course, any information, if two-dimensional can show it really well, yeah, by all means, do a 2D visualization. And it's easy to communicate because our computer is flat. And if you send somebody a PDF, send somebody attach image in your email, and if it has a hidden 3D information, it's often confuse people. But in reality, there's like when we deal with the complex information, the two-dimension is quite limited, and we don't understand like 2 to 3 is not like a 2 plus 2 equal to 4. It's really a order magnitude jump. It's more like a 10 to 100 to 1,000, that kind of a leap. Is having another dimension really allow you to simplify your views, simplify your presentations, and allow people to focus on the things that need to focus, and without being disturbed by the information, other information you can put in the background. One example I like to see is how we observe forest. Like forest is like a natural 3D thing. If you're trying to smash forest together into a 2D plan, and it does not make sense, it gets too difficult. And yeah, I think there's a place for 3D visualization, especially for complex structure information, like this thing you just discussed, the structural, the hierarchical information of the company, organization, and the process flow aspect of it, and then you have the instance like real like instantation of jobs, tasks, and all those informations. You trying to visualize them in the same way, like without like people looking at like get lost. Like what is it? It's like I see a whole bunch of symbols, but what does it mean?
But what does it mean? Yeah.
Yeah.
I've found that as we work with the 3D models, and we're using it now with just more basic data, right? So I'm not talking construction data per se, but just normal data sets, and you can actually move them around and you can start to see different relationships in the models. So whilst, you know, Power BI models and dashboards are all great, like you said, 2D, flat, written with a question in mind, when we start doing the 3D modeling, our brains automatically run to the questions. Why is it doing that? Why did it do that? Why is that a bigger shape than this? Why is this cluster stronger over here? But why have we got these outliers over here? What does that mean? So it gives us an ability, I think, to just ask some amazing questions and some simple ones, and I think it helps us move and position change. A lot more effectively than we've been able to do it in the past.
Yeah, exactly. So Jackie, also, I think we often forgot learning to interpret data is a learned capability, ability. However, we all grew up with the ability to like dissect a 3D environment, with like deal with, like, know the relationship between objects. Like I have this glass on the table in front of my computer, so it's a natural connection graph that we very intuitively, our brain can process those kind of information really well. So like the traditional BI tool is great because it serves its purpose, like you said, like answer specific questions, and also people learned how to interpret them. The graph visualization done right is like in the 3D, because now you represent the data point as objects. Once you represent data points as object, you suddenly engage all our ability in dealing with objects, in relating to the objects, and drawing connections between objects. And that is where this is a field that I wish I have more time to do some research and really be able to quantify how much we gain by viewing information as object rather than a trend line, a table. The table is the worst. Like, look at the table, you just like your eye glows over. It's like start snoring.
Whereas now, I mean, you know, when I've been working on the projects I've been working on, and we've pulled really quite large data sets together, it's like you automatically know what to look for. So it's like, what's that small blue dot there?
Exactly.
And why is it there? So all of a sudden, I've now known that as a blue dot.
Yeah, the blue dot. Yeah, that blue dot. Yeah, rather than, hey, what is that number mean?
Yeah, it takes on a whole new meaning. So, okay, so are all blue dots equal? Are all orange dots equal? So, yeah, I just find it fascinating now because we've got the data behind it. So whilst we can say in very simple terms, we've got a blue dot, if we click on that blue dot, we can actually look what's behind that blue dot. And we can, you know, if we've put the right data set together, we can start to tell the story of why that blue dot is there. So I find that fascinating. And I think now most people who are leading organizations and leading teams need to get across this, need to be across this. This is a skill that now, as we're all working with just huge amounts of data, we need to build, and we need to build it quickly.
Yeah. The biggest challenge is overcome tradition. Like once organization has a way of working with the data in certain way, changing is often really hard. And I think it's a lot of it is in like people like you and I to demonstrate the value of graph. Like if 85% of the data lake eventually go into the garbage, if we can reduce the number to say 60%, that's a huge gain already.
I would ask the question, why do we need the data lake in the first instance? Because we've now got the ability to take the data from source. So, you know, it doesn't matter where the data sits. if we're meshing it into a data lake, let's just say over time that becomes the data swamp, becomes thick and infested, and we just say it's all too hard, but it's cost us a lot of money. Whereas the value is coming from the transactional systems themselves, the informational systems themselves. So if we can put a tool set across the top of those, and it doesn't matter what the data is, we've got that ability to bring it up, to bring it together and analyze it in its true sense, rather than putting it into a data lake.
Yeah, exactly. So I think there's data mesh and there's data fabric approach these days. And they are very promising. And my opinion is be practical and like just often like trying to do the things you think it's correct. It's like getting the places where it's very costly and very messy, very expensive. Like especially with the explorative workload. So this is my opinion. If your work nature is explorative, a data fabric or a data lake approach is often heavy. Like you have to reconcile your data, clean your data before you can work with the data. That's too slow. A data mesh approach is like I can grab the data from this part and that part and that part and bring them into GraphXR, and they come up with a connected graph, and I can reason over it immediately. That really is the right way to go. Now, once you go through this and you have to go into the real-time operation. There's a value for data fabric and have to bring the data to a common place that they can do ongoing analysis. That's become very clear. And I just ran into one case that the organization saved the data for like a half year because it's very costly, but then it's quite clear that the past couple years the data, they are actually quite important in doing a lot of forensic analysis, but those data are already gone because it's too costly to save, and they regret it.
Well, that comes back to the value question, doesn't it?
Exactly.
What are we spending our money on? And if there is regret in not being able to store data, then maybe the value should be in storing the data, and so budget has to come from somewhere else in order to save it.
Yeah, exactly. And some of the data is just so humongous. We work with the cybersecurity NGO. They have such massive data, they just cannot store it. It's just too big. But at the same time, they know there's a value in the data, and I'm always like my saliva is always drooling when I look at the data. But
you've got a sad life. You've got a sad life if you're drooling over data. I just go, oh no, not more of it. How much more does my brain have to absorb? Yeah. So we're slowly running out of time, and I'm conscious of your time too. For people who are starting on the data exploration journey, where do they start?
I think we have a set of blogs on the Kineviz Medium blogging site that has a lot of examples, like guiding people how to start with using graph analysis. One of the good example is Game of Thrones data set. I think most people, at least you heard about Game of Thrones, know there's a lot of people killing each other. and there's actually organized the data set of recording who killed who and who belongs to which house and which episode did that happen. And that data set is actually a fantastic example of all those information gets captured, but how do you visualize them in a very intuitive and direct manner? So you can those example or our blog sites, you can find them.
All right. Well, I'll put links to those on the recording so people can find it. So I just want to say thank you, for giving your time, because I know you are away from home at the moment. Thanks for all you do in this data space.
Yeah.
And we've worked together for a little while now, and I'm just continually amazed by what we're able to do with data and what we've done with the Kineviz tools and with you and Sonny as well. So for that, I thank you.
Well, thank you so much, Jackie. This is a very insightful conversation. I love it.
All right, great.
And you guys doing amazing work.
Well, let's hope we stay that way. Let's hope we stay that way. Yeah, I think this last project, I think I may not be sad to see it go. Sorting through hundreds, 100,000 documents is just unbelievable. But anyway,
it's hard.
That's a story for another day.
Yeah.
All right. Well, thank you so much. It's been great. And we look forward to seeing what Kineviz does in the future.
Thank you. You have a wonderful day.
Yep. Thank you.